So we're going to talk about averages. By average, we in English, when we say average, we mean something about typicality. And generally, to be very specific, when we say average of two numbers, we add the two numbers and divide it by two. That's how we use the word in English. But in math, that has a very specific meaning. It's called arithmetic mean. So let me take this to my other slide. So when we try to calculate average in the real world, we tend to do this. Let's say, what's the average of 2 and 3? We add 2 to 3 and divide the answer by 2 because we're adding two numbers. But in math, this is called arithmetic mean. Arithmetic mean. So let's find the arithmetic mean of three numbers. And let's say the numbers are these numbers, 5. So let's say the numbers are 5, 3, and 2. And I want to find the arithmetic mean of these three numbers. And that's going to be 10 over 3 is equal to 3.333. Okay, that's the arithmetic mean of these three numbers, 5, 3, and 2. So this is not the only way we can find typicality. Okay, so let's say I'm still talking about this set of numbers. Okay, 5, 3, and 2. Okay, and that's how we find the arithmetic mean. It's called the arithmetic mean. I'm just going to write AL, arithmetic mean. Fine, no problem. Okay, what's mode? MODE. What do we mean by mode? Well, mode is the most frequent number. Let's say this time around, my data set is something like this. 5 shows up twice. Since 5 is the most frequent number, the mode is 5. Mode is 5. Now, what if you have something, your data set is something like this, right? Your data set has two 5s, two 2s, and a 3. It's called bimodal. Your modes are 5 and 2. So you have two modes because 2 and 5 are the most frequent numbers. Now, here, if I put another, now, what's the mode of this data set? Well, 3 is the most frequent number and it's unique. Only one number is the most frequent number, so the mode is 3. All right. What do we mean by mid-range? Okay. So I'm going to keep this here. Well, this is, I need the room, so I'm going to delete these. Now let's talk about mid-range. Okay. Mid-range is simply, I can talk about the same data set. Mid-range is simply this. If I am considering this data set, you need to find the highest number and the lowest number. You need to add them up and divide the answer by 2. Basically, to find the mid-range, you first determine the highest number, then you determine the lowest number, then you add them up and you divide the answer by 2. So let's find the mid-range here. Mid-range. The highest number in this data set is 5. The lowest number is 2. And you always divide it by 2. And you only focus on the highest and the lowest number. And 5 plus 2 is 7. 7 divided by 2 is 3.5. That's the mid-range of this data set. Okay? What's the median? Let's talk about the median. I don't need this anymore. The median, this is how we find the median. And median is a very important concept. It's used often. Okay. The median is you need to rank or order the data, okay, starting with the lowest first. So I'm going to keep the original data here so that I don't lose it. If I rank order the data points, I get something like, if I do it carefully, I get 2, 2, then 3 threes, 5, 5. Excuse me. Now, to find the median, if the data set has odd number of points or odd number of elements, median is the one in the middle. This is the median. 3. But first you have to rank order it. Okay, so we're going to write median is 3. What if, let's say, in my original data set, I had something like, let's make this 3, 5, and let's add another 5. Now, first, I'm going to rank order my new data set, which is a new set. I know it resembles the first one, but we know it's new. And I'm going to calculate the median. So what do we have? The lowest numbers are 2 and 2. I have two twos. The highest numbers are, sorry, not the highest. There are 3, 2 threes. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers, so 2 twos. And one way to keep it straight is like this: 2, 2, 3, 3, 1, 2, 3, 4, 5. So I have 5 fives. 4 fives, sorry. Now, I have a data set that has 8 data points. Okay. Now, I have 8 data points. Since this is not odd, I'm going to look at the two of the middle numbers, add them up to find the median, add them up divided by 2. So I'll give you a little summary. So to find the median, first we have to rank order the data. Then we'll look at the middle 1 or 2 numbers. If the data set has odd number of points, there'll be one number in the middle. That'll be your median. Done. If the data set has even number of points or even number of numbers, that's why we say points. We don't want to say number of numbers. You add the two middle numbers. First, you rank order the data set. You add the two middle numbers and divide it by 2. You get the median. Done. Now, averages are not the only thing we study. Typicality is average. We also study something that's called, these notes are here, but I did explain things in the video. You can take a look at these examples. Okay. All right, we're going to move to our second topic. The second topic is spread. Okay. The second topic is spread. The range, interquartile range, variance, standard deviation. Okay. So we're going to talk about some of these things. So what is spread? I'll give you an example. Okay. I'll give you an example. Why do we care about spread? So let's have two data points, two data sets. Okay. The first one is 7, 11, and 15. Okay. And we are going to find the arithmetic. Well, this is my data set A. And let's say my data set B has 3 numbers in it. And it is 0, 22. Okay. So let's find, excuse me, let's find, I need the calculator. Give me a second right here. So let's find, we're not getting into spread yet. We're trying to ask, why do we care about spread? What is spread? Take a look at the first data set, 7 plus 11 plus 15 divided by 3. The arithmetic mean is 11 of the first data set. And the second one, we're going to call it B, not 0, is 0 plus Now, in the second data set, the average or arithmetic mean is still 11. Take a look. Okay. 7 plus, excuse me, 7 plus 11 plus 15 divided by 3 is 11. And 0 plus 22, and I can even put 0 here, no big deal. 0 plus 11 plus 22 divided by 3 is also 11. But there is a difference between the two sets. The numbers are more spread out in set B, spread out, and the numbers are less spread out in set A. So people calculate spread of data sets. Okay, it's called measures of spread, and it can be measured using range, which is a very simple concept, interquartile range, variance, and standard deviation. So we'll work on some of those ideas. Range, okay? A very basic concept, and I'll be happy to go over it. The range of a data set is the difference between the largest and the smallest values in the data set. So here, if you look at the data set, it hasn't been ordered, but 70 is the highest value, 3 is the lowest value. You simply find the difference and you have the range. It's a very easy, simple way of measuring how spread out the data set is. Okay. Wow. There is another way we measure spread, and I know it's a lot here, but we're going to see how we deal with it. Range is a fairly straightforward concept. What are quartiles? Okay. The second quartile is the midpoint or median of the data. I know I listed second quartile first. It is simply the midpoint or the median of the data. To find the second quartile, you do exactly what you would do to find the median. Okay. What is the first quartile? Well, it's the point right after the first quarter of the data set, assuming you're starting with the lowest and ending with the highest, after you've ordered it in ascending order. Quartile one is right after the first quarter of your data set. And quartile three is the one that's after 75% of your data set. Now, I'm going to take a very simple example here to make sure the concepts are clear, okay? So let's say your data set is three. I'm going to order it 5, 6, 7. I'm going to find all the quartiles. All right, guys? 7, 7. Let's make it 7. Okay. This is my data set. I'm going to call it set A. Okay. Now, it's rank ordered, okay, in ascending order. So first I'm going to find Q2, and it's written Q subscript 2. Q, looking for subscript. I don't know why I can find it. Right here. Again, I'm finding Q2 first because that's simply the median. Just find the median, you have Q2. Okay, here the median is the middle number. I have 7 points in my set A. Median is the middle number, which happens to be 6, and that's 6. Now, to find Q1, it's the 25% mark. All you do is look at everything on the left of 6. You don't take 6 into account. Everything on the left, and find the median, everything on the left of the median, and find the median of these three numbers again. Okay? And that's going to be my Q1. And I can't call it a median anymore. It's the first quartile. And the first quartile, by focusing on those three numbers, apply the same rule for finding median. But this time you're looking at the median of all the numbers that are on the left of Q2. And that's going to be 3. That's going to be your Q1. And leave it here. Leave it here. How do you find Q3? You kind of do the same thing with the data set on the right-hand side of the median. The data set is here. And if you just focus on this data set, and the median of this data set is Q3, which turns out to be 7. Have it. We have Q1, Q2, Q3. It's not a very difficult concept. Now I'm going to save this here. I'll do some other problems and use the same data set because we already found Q1, Q2, Q3. Now you learn how to find Q1, Q2, Q3. All right, let me take a new slide. Let me go here. So in your notes, there are tons of examples. Take a look at them, okay? Now, what's interquartile range? IQR. So interquartile range is a fairly straightforward concept, guys. IQR is the difference between the third quartile, Q3, and the first quartile. What does that mean? Well, you just look at Q3, which is 7, minus 3. 7 minus 3 is 4. So for this data set, IQR, IQR is 7 minus 3 is 4. IQR is 4. Done. Okay. So we have learned about range, interquartile range, what's Q1, Q2, Q3. We're going to talk about variance and standard deviation. This is the third way we measure um, spread. So how do we find variance? It's a little messy process, okay, guys? And sometimes people will ask you to show your work when they ask you to do it. So to find the variance, I'm going to actually do this by hand for you guys. All right, guys, you have to do it by hand. So I can just read my slide, but that's not going to make a whole lot of sense. Now I'm going to keep my work here so that I can check my answers, okay? So how do we find the variance? Let's do it slowly. To find the variance, first off, you have to find the mean or arithmetic mean, which turns out to be 3 plus 1 plus 70 plus 9 plus 17. And how many numbers are here? 5. Okay, you have to find the arithmetic mean first. How do we find that? Well, all we have to do is do 3 plus 1 plus 7 plus 9 plus 17. 74, 70, 100. Well, that's nice. 100. If you take 100, and since there are 5 numbers, you divide it by 5, you get 20. So the arithmetic mean is 20. I'm going to go check my work and make sure I didn't make a mistake so far. So it's 20. Okay. Now here, I'm going to take each of the numbers and subtract the arithmetic mean from each number. With me? I'll do it. Um, so let me do it on Excel. Okay. It'll be a little better. All right, guys. Let me open Excel and do it that way. 3, 1. Okay. Let me make it a little bigger. The numbers we have are 31709 and then 17. 3, 1, 7, 0, 9, and 17. Now, our arithmetic mean is 20. We know that, right? That's 20. You can, of course, find the arithmetic mean on Excel, which I won't do. Well, I'll do just to check, okay? Just to check. Well, let's just find the sum. Just find the sum. No, it's just 70. I don't know why I keep writing 700. Fine. And if you divide 100 by 5, you're going to get, so our sum is, our arithmetic mean is correct. All right, I'm going to delete this. So in the second column, we subtract, you start with 3, subtract 20. Great. So it's going to give me date. That's very frustrating. So guys, what we're going to do, unfortunately, we'll have to do it like this. I don't want Excel to give me the answers. Okay. Give me 1 second. So I'm going to enter 3 here. So we'll fix it. 3 minus 20, your arithmetic mean. Then you're going to do 1 minus 20. Then you're going to do 70 minus 20. Subtract the arithmetic mean from each number. And my data set is 3170970, 31709 and 70. You need a little, we have to be a little patient. Minus 20. 17 minus 20. No. The answers are going to be, I'm going to be listing them here. This equals to what, guys? You're going to say this equals to 3 minus this column. This will be negative 17. This will be, and you have to do it using your calculator. Okay, negative 17, negative 19, positive 50, negative 11. That looks about right. Now, this is what we did. It's all here. Make sure you understand what's going on. Okay. Now, 20 is the arithmetic mean. Arithmetic mean is 20. Now, in this column, I'm going to square these numbers. Okay? Square means you multiply the number by itself. I'm going to just do it here if you don't mind directly. I'm going to square these numbers. Okay? In the red column, I am squaring all these numbers. Now, I have to add them, okay? I'm going to find the sum of all these numbers, 289, 361, 2,500, 121, and 9. Just a sum. And I am going to bring it elsewhere, actually. And I'm going to use a different color, green. Now, since I had 5 data points, I'm going to divide this sum by 5 in a second. Let me just show you something. I just want to check 3280. I hope I got 3280. That's a good sign. I didn't mess up. So I'm going to divide it by 5. Basically find the arithmetic mean of the numbers in the red column. And what is 328 divided by 5. This number 656. Okay. Again, I took these numbers, negative 17 squared it, got 289, negative 19 squared it, got 361, 50 squared it, got 2500, negative 11 squared it, got positive 121, negative 3 squared it, got 9. So this number 656 is it's actually called the variance, interestingly enough, okay? All I have to do to find the standard deviation. So this is your variance. Let me see what I can do. Let me compress it a little bit. This point. All right. This is the standard deviation. Variance, my bad. Variance. Now, we need to find the variance before we can find the standard deviation. I'm going to write SD. So SD is basically the square root of this number, 656. Find the square root of the variance, and you're gonna get the standard deviation. And the square root of the variance is about 25.6125. So I'm going to go over this again. You take the data set. You don't have to rank order them. You have to find the arithmetic mean. Then from each point, each number, you'll subtract the arithmetic mean and look at those numbers. Okay? Then some of the numbers will be negative, some of the numbers will be positive, and you have to square them. Once you square them, you find the arithmetic mean of this new set of larger numbers. They're all going to be positive. If you have 5 numbers here in the red box, you're going to divide it by 5. Whatever you get is called the variance. And then when you find the square root of the variance, you're going to get the standard deviation. I'm going to check my answer just to make sure I don't mess up. It's a different data set. Let's go back. Let's go down. Yeah, it's essentially the same. My variance is 656, and the square root of 656 is 25. I'm going to double check again. That is 25. So we're good. This is our standard deviation for this data set. Okay, guys, we have one more to discuss. I have multiple examples. Basically, it says find the variance and find the standard square root. So I have another data set. You can practice this. So what is the mean absolute deviation of a data set? That's simply, basically, in the column, when we square it, instead of squaring it, we take the absolute value. And that simply means if you get a negative here, it becomes positive. So what I'm going to do, guys, I'm going to find the mean absolute deviation right here. Right here. Okay, you have an example here, but let's say I want to find the mean absolute deviation here. All right, so I'm going to hide this. Okay, everything is like before. You need to find the mean, arithmetic mean, you need to subtract, but in this column, you don't square. So you find the absolute value. What's the absolute value? I'll explain it to you in a second. So absolute value of negative 17 is positive 17. And these are my absolute values. And they're basically, you're ignoring the negative sign. I'm going to make this box red. All right. I don't need the text to be red. Okay. Then I'll find the sum and I'll divide the answer, whatever I get. If I have 5 data points, I'll divide it by 5. And that's going to be my mean absolute deviation. And the abbreviation is kind of funny. MAD. It's going to be 20, 100. Let me go back and check my answer just to make sure I didn't mess up. Yeah, it's 20. So once again, mean absolute deviation is very similar to standard deviation. To find the standard deviation, you have to find the variance, then you have to take the square root of the variance, you get the standard deviation. That's a complex process, right? Mean standard deviation is similar to mean absolute deviation, or MAD, is similar to standard deviation, but easier. Let's see what else do we have. All right. We're going to see in this chapter box and whisker plot. Okay. This is what it looks like. Sometimes you're going to see a horizontal picture, but it's really the same. So to draw or understand mean and whisker plot, I'm sorry, let's go and talk about box and whisker plot. This is called a box and whisker plot. It's called box and whisker. Box is the middle portion and whiskers are the two endpoints. This is how it's done. Let me take this and explain it to you on a different slide. Need to move this guy. Let me take a nice picture. All right. So to find or draw box and whisker plot for a set of data, you need to know the largest number. You put a little hatch mark right here, and then you need to find the smallest number, which is very easy. You rank out of the data. We also learned how to find the first quartile, the third quartile, and the median or the second quartile. And you put a little rectangle or a box around the three quartiles like so, and you have a box and whisker plot. So it's a very easy graph. It's very common. You're going to see it in newspapers. So you have it. So that kind of wraps up our statistics section.